Yeah, good morning to all. Myself Prabhaharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is signal flow graph from unit 1, which is control system modeling. From the subject name is linear control systems. Yeah, let us discuss. Signal flow graphs is an important graphical method used in control system to represent a relationship between system variables. This method helps us to analyze complex systems in a clear and structural way. Okay, students often face confusion while drawing signal flow graphs. The first difficulty is correctly representing system variables as nodes. The second difficulty is assigning the correct direction to branches. If the direction is wrong, the entire system behavior may be incorrect. Let me discuss the basic elements of flow graph. A signal flow graph consists of nodes and branches. Node represent the system variable and branch represent the functional relationship between variables. There are three types of node. First one, input node, which has only outgoing branches. Then output node, which has only incoming branches, and then mixer node, which has both incoming and outgoing branches. Let I discuss the SFG, which means signal flow graph terminology and rules. The first one is forward path. A forward path is a path that starts from the input node and reaches the output node without passing through any node more than once, which means no node should be repeated in the path. Here you can see the diagram on your screen. There is one path, one forward path. Okay, and the second thing is loops. A loop is nothing but the it is a closed path that starts and end at the same node without repeating any node. Loops represent feedback in the system. Feedback in the sense the part of the output signal is fed back to the input signal, which is called feedback. And third thing is non-touching loops. Non-touching loops are loops that don't share any common node, which is called non-touching loops. Loops and non-touching loops already we have discussed. Let me discuss the loop gain. The loop gain is calculated by multiplying all branch gain along that loop. In other words, we take the product of all transmittance in the loop, which is nothing but the loop gain. Let me do one small classroom activity. The question you can see on your screen itself. You have to find the value of question mark. Let I discuss the determinant. What is mean by determinant? Determinant is also represented by delta. It is also called delta. Delta or determinant is calculated using the formula. The formula you can see on your screen. Delta, which is equal to 1 minus the sum of individual loop plus the sum of product of two non-touching loop minus the sum of product of three non-touching loops, and so on. Notice the alternating signs in the formula. Yeah, let I check your understanding through the assessment quiz. Here we have two assessment quiz. First one is in a single flow graph, a node that has only outgoing branches is called which one is correct? Option A, option B, option C, or option D. Option C is correct answer, which is source node. And we will move to second question. A forward path in a signal flow graph is defined as the correct option is B. which is a path from input to output without repeating nodes. First question, option C is correct. Second question, option B is correct. Okay. Okay. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.